Hi there, it's Ruth, and today we'll be looking at percent yield. Percent yield is a comparison between the actual yield and the theoretical yield. The actual yield is what you get when you carry out the chemical experiment, and the theoretical yield is the data you get when you do your stoichiometric calculations. The statement reads, hydrogen gas reacts with nitrogen gas to produce ammonia. If 5.4 grams of hydrogen gas are reacted with 27.3 grams of nitrogen gas, determine the limiting reagent in this reaction. If you conducted this reaction and obtained a yield of 20.5 grams, what is the percent yield of the reaction conducted? All right, so we're asked to do a number of things. First thing we're asked to do is to determine the limiting reagent of the reaction, and then we're asked to calculate the percent yield. So let's focus on the limiting reagent first. But even before we think of the limiting reagent, we have to derive the chemical equation. So we know that we have hydrogen reacting with nitrogen, and we're told that they produce ammonia. But when we take a look at our equation, we see that we have 2 moles of hydrogen on the reactant side and 3 moles on the product. So this is definitely not balanced. And if we look at nitrogen also, we have 2 moles on the reactant side and only 1 mole on the product side. So we need to first balance our hydrogens. Okay, so check our hydrogens. We have 6 moles on the reactant side, 6 moles on the product. But then for the nitrogen, we now have 2 moles on the product side and 2 moles on the reactant side. So we're good. We're going to next calculate the moles of reactants present. And we'll do so using our triangle. Moles is equal to mass over molar mass. So we need to calculate next molar masses of our reactants. Okay, so the first reactant, hydrogen, we have 2 moles of hydrogen, and hydrogen has a molar mass of 1.008 grams per mole. All right, and we get that data from the periodic table. So this will give us 2.016 grams per mole. And our nitrogen, we have 2 moles of nitrogen, and nitrogen is 14.007 grams per mole. And if we multiply that by 2, we should get 28.014 grams per mole. All right, so next step, calculate the moles of hydrogen present. Okay, and that is mass of hydrogen divided by the molar mass of hydrogen. And the question tells us the mass of hydrogen. We're told that we have 5.4 grams, and the molar mass is 2.016 grams per mole. We see that our grams will cancel out, and we're essentially dividing 1 by per mole, which will give us moles. 5.4 divided by 2.016 going to give us an answer of 2. Let's keep it to 3 significant figures. 2.68 moles of hydrogen. Okay, next let's do the moles of nitrogen present. We know that's going to be equal to mass of nitrogen divided by the molar mass. Question again tells us that we have 27.3 grams. So 27.3 grams, and we calculated our molar mass 28.014 grams per mole. So when we do that division, 27.3 divided by 28.014, we have an answer of 0.97 moles of nitrogen. So we calculated the moles of each reactant present. So let's look at what we've done so far. We derived our balanced chemical equation between hydrogen and nitrogen to form ammonia. And we calculated the number of moles of hydrogen and nitrogen present. And if you recall, hydrogen 2.68 moles and nitrogen 0.97 moles. So we want to use these two molar quantities in our balanced equation to see which one will produce less ammonia. The one which will produce less ammonia will be deemed the limiting reagent because it will be used up completely in the chemical equation. So let's look at the relationship between hydrogen and ammonia first. Okay, the equation tells us that for every 3 moles of hydrogen that is reacted, we will produce 2 moles of ammonia. And that's the relationship. So if we have 2.68 moles of hydrogen, how many moles of ammonia would we form? That's our unknown. That's what we're trying to find. We could cross multiply to find this. So it will be 2.68 moles hydrogen times 2 moles ammonia. And that'll be divided by 3 moles hydrogen. And you could see that the moles hydrogen will cancel out and we'll be left with moles ammonia. So when you do your calculation, 2.68 times 2 divided by 3, that will give us 1.79 moles of ammonia. Therefore, if we react 2.68 moles of hydrogen, we will form 1.79 moles of ammonia. Let's look at the relationship now between the other reactant. So let's look at nitrogen and ammonia. That mole ratio tells us that if we react 1 mole of nitrogen, we will form 2 moles of ammonia. So how many moles of nitrogen do we have? 0.97 moles of nitrogen. And now we want to know how many moles of ammonia that will form. Again, we can cross multiply 0.97 moles nitrogen times 2 moles ammonia, and that will be divided by 1 mole nitrogen. Again, you will see that the moles nitrogen here and here, they will cancel out and we'll be left with moles ammonia, which is what we want. We want to calculate the number of moles of ammonia which will be formed. So 0.97 times 2 divided by 1. So 0.97 moles of nitrogen will react to form 1.94 moles of ammonia. So let's now compare our quantities of ammonia produced. We're told from our stoichiometric data that we can form 1.79 moles of ammonia with hydrogen, or we could form 1.94 moles of ammonia with nitrogen. So the fact that hydrogen forms less ammonia, it means that hydrogen is in fact the limiting reagent. So we've done one thing so far. We have determined the limiting reagent, and that limiting reagent is the hydrogen. So a bit more information. The question tells us, if you conducted this reaction and obtained a yield of 20.5 grams, what is the percent yield of the reaction conducted? We could use the equation percent yield is equal to actual yield over theoretical yield times 100. We are given the actual yield here because we're told that this is the mass obtained when we do the experiment. So technically we'd be expected to calculate the theoretical yield, and we could do so by using the moles of ammonia calculated on the previous slide, and by again referring to our triangle where moles is equal to mass over molar mass. So we're expected to now calculate the molar mass of ammonia. And we could use our periodic table to help us, and we know the formula. We have 1 mole of nitrogen, and the molar mass of nitrogen is 14.007 grams per mole. And we have 3 moles of hydrogen, 1.008 grams per mole. So this will give us the molar mass of ammonia, 1.008 times 3 plus 14.007, and that gives us 17.031 grams per mole. That's our molar mass of ammonia. And we know the moles of ammonia, and we did that calculation on a previous slide. We said that's 1.79 moles of ammonia. Now, if we look at our triangle, we know that mass is equal to moles times molar mass. So mass, or theoretical mass in this case, is equal to moles of ammonia multiplied by molar mass. The moles of ammonia, 1.79 moles, and the molar mass is 17.031 grams per mole. Again, this could also be written as that, however you feel comfortable. 1.79 times 17.031, and I'm going to report to 3 significant figures, so this will be about 30.5 grams of ammonia. So that's the theoretical yield, and we know the formula for percent yield is the actual yield, which we're given here in the question, 20.5 grams, and we said that the theoretical yield is 30.5 grams. We're going to multiply that by 100. So 20.5 divided by 30.5 times 100 is about 67.2%. So that's our theoretical yield. Again, thank you so much for sticking through to the end of this video. Again, please feel free to leave any comments if you have any questions at all. Thank you so much, and take care.